So another inclined plane problem. We might be at the airport here and sliding a parcel down a slope, or outside mucking about in the playground. I don't know. Let's have a look what mechanics would tell us about the time to slide to the bottom. So here we have the question and the diagram that we've been given. And as is usual with a question like this, the first thing I'm going to do is to add the forces to make a force diagram. So we have the weight of the particle, 7g. We have the normal reaction from the plane, and we have the friction opposing the motion. So when I resolve down the plane, I've got the component of the 7g force, which is 7g sine 12 down the plane, and then I've got friction opposing that motion. So 7g sine 12 minus friction is the resultant force down the plane, and that equals mass times acceleration. When I resolve perpendicular to the plane, I've got r in this direction and then 7g cos 12 in that direction. So r minus 7g cos 12 is the resultant force, and that equals mass times acceleration. Well, acceleration in that direction is 0. So from that I can see that r is 7g cos 12. We know that the parcel is moving down the plane, and so the friction is equal to mu times r. Mu is 0.15, we've been given. The reaction we've just calculated. So the friction is 10.07 newtons. So now we can put that 10.07 newtons back into this equation. And when we do that, we've just got one variable now, or one unknown, which is a. And then a is 0.6 meters per second. So the acceleration is going to help me now, because I want to find the time it takes the mass to reach the bottom of the plane, and the plane is 2 meters long. So the acceleration that we've calculated is going to be a constant acceleration, and so I can use suvat. So displacement is 2, the initial velocity is 0. I'm not interested in the final velocity. The acceleration we've just calculated is 0.6, and I'm calling the time that we're interested in capital T. So I want the suvat equation that doesn't have v in it, and that's s equals ut plus half at squared. So putting the values in, u is 0. I can then calculate t to be 2.58 seconds. Quite a slow progression to the bottom of the ramp, perhaps. So my assumptions are that the mass is a particle and that g is 9.8. So there we are.